Hello everybody, welcome back to yet another video of FikarNot.com. Now FikarNot from studies. So today we are going to be talking about the one and only energy. But a little twist to it, because this is not the energy that we see in biology. Well, this is the energy that we see in physics. A little more mathematical and a little more logical. So, for the people who excel in mathematics and logic, well, this chapter is so for you. And for the people who don't worry. I will make you excel in it. Okay, so without further ado, let's start with this chapter. So, energy. We know that work cannot be done without energy. The amount of energy possessed by an object is equal to the amount of work it can do when the energy is released. So this is a saying, and this is proper logic as well. Imagine you have ton of energy in your body, okay? And you want to use that energy on pushing some blocks. So you have ton of energy in your body and you want to use this energy in pushing some blocks. So you take this block and you push it in this direction. Not even one. You do 10 of these blocks. And you push it about, say, 10 meters of a distance. Totally, you say 10 into 10 into 10. So you almost go till 1 kilometer. Pushing 10 boxes. But if there would not be work, and work wouldn't exist at all, where will you put this energy? Thus, we can conclude that energy and work are correlated. Without energy, we cannot do work. And to do work, we need energy. So, the amount of energy possessed by an object is equal to the amount of work it can do when the energy is released. Thus, the amount of work or energy is measured by the amount of work done. Hence, energy is the capacity or ability to do work. Definitely is the capacity to do work. If you have, say, 10 meters worth of energy. This is not an actual metric value of energy. It's actually joules, which you'll get to know more. But I'm just telling it in meters so some of you understand up there. So let's say you do 10 meters of work. Or let's say 10 joules of work itself. So you're most likely to do only 10 joules of work. Right? If you have 10 joules of energy, you will do 10 joules of work. If you have 11 joules of energy, you won't do 12 joules of work because you have that much energy. That is why energy is the capacity or ability to do work. So underline this line in your textbook. It's really, really very important. Now, let's talk further about the work and energy relationship. So when we play cricket or badminton for a long, long time, we get really tired for sure. Say I play badminton for 2 hours because I really like badminton. So I play badminton for 2 hours. And this is because, and why do I get tired? Well, this is because I spend my energy in playing. Right? So, over here comes a little biology too. Our energy is related to work because the energy from our body is getting not wasted exactly, but used onto the work we do, which in this case is playing badminton. And that is why work and energy are related. Because we need energy to do work. To do more work, we need more energy. Thus, energy and work are correlated. Energy must be supplied to an object so that it can do work. Moreover, when work is done on an object in changing its state, the total amount of work done is equal to the energy possessed by the object. For example, when we move a stationary object, okay, so you're moving a stationary object in, say, this direction. work is done on the object for sure, because you are moving it in this direction and the object is moving as well. The moving object possesses energy equal to the work done on the object. So the object may. So wait, let me make this a little more clearer for you. The object is possessing some energy on its own. That is why it is able to move. Besides the point that we are moving it, that and we have energy in our body. Why are we moving the object? Because we had the energy to move it. And why is the object moving? Because it has the capacity, the energy to do so. Similarly, when we lift an object to a certain height, we do some work against the force of gravity. This work is equal to the energy possessed by an object at that height. So, we can conclude once again that work and energy are correlated. We're going to talk more about this in a few more minutes. So all of this will become absolutely crystal clear to you. Now, the units of energy are, since energy is the amount of work done on an object, therefore the unit of energy is same as that of work. So it's like energy and work. These two brothers are together. They have the same surname, which is Joule. And they have one more surname, that is the CGS unit one, which is created by themselves, which is called the erg. So these both terms are brothers. Work and energy, the bestest of the bestest buddies. They have the surname of joules, which aka in physics is called as the SI unit. And they also created their own surname, which is called as erg, which again aka also known as the CGS unit in physics. Okay, let's go on to the next one. So throughout all our sciences that we study about, be it chemistry, biology, or even physics, we have different forms of energy, such as mechanical, heat, light, chemical, sound, magnetic, electrical, and nuclear. So all of these are different forms of energy. Some of them also include bio, some of them include chem, and others of them include physics in them. So energy is present everywhere, be it any subject, but you need energy. Even to study this chapter, you need energy in your body, or else you will be sleeping. Okay, but here we will discuss only about mechanical energy and its types. So from all the different forms of energy I just told or recited to you, we will only be focusing on mechanical energy and its types. So mechanical energy. What is mechanical energy? The energy possessed by an object due to its position or state of motion is called mechanical energy. So I'll repeat once again. The energy possessed by an object due to its motion or state of motion is called mechanical energy. Well, this means that when an object is moving due to its speed, you can say, or its mass, or its position, all these factors come under mechanical energy. And that is why we say that the energy which is possessed by an object due to its position or state of motion is mechanical energy. So mechanical energy are of two types, kinetic and potential. Kinetic is a way up there once again, because kinetic energy is almost used in everything we do in our day-to-day lives. So the mechanical energy is the sum of kinetic energy and the potential energy. It's almost like I say, what is 2? 1 plus 1. Over here, 2 is the mechanical energy and 1 plus 1 is the potential and kinetic energy. An object is said to have mechanical energy when it possesses either potential energy or kinetic energy or both. A moving car, an arrow on a stretched bow, an oscillating ceiling fan all possess mechanical energy. Now, tell me, why does a moving car possess kinetic energy? Well, solely because this is dependent on its state of motion. with what velocity or speed is it moving? Similarly, when a stretched bow, when it is thrown or when it is left to go and touch some surface or a wall or anything of such, when you're stretching it, if you stretch it more backwards and more higher, like let me take this. So this is a bow, and if I take this arrow and if I stretch it a lot, so the velocity will definitely be more. While if I only stretch it a little, it'll probably come over here and it will fall down. So again, this is an example of mechanical energy. It can either be kinetic or potential or even both. So let's go in a little more detail of kinetic energy. So the energy possessed by an object due to its motion is called kinetic energy. It is usually denoted by Ke or E. A free falling stone, a car moving on the road, a ball rolling on the ground, a bullet fired from a gun, flowing water, an oscillating pendulum, all possess kinetic energy. So, when an object initially at rest is made to move, work is done on the object. And the object in motion possesses kinetic energy. This kinetic energy on the object is equal to the work done on the object. So, some of the factors affecting kinetic energy of a moving object will be the mass of the object and the speed of the object. Now, all of you may be so confused. Ma'am, at least tell us what kinetic energy is. Well, among few of the examples you guys just saw a few minutes ago, I'll explain you how kinetic energy is dependent, or the factors that affect kinetic energy is the mass of the object and the speed of the object. So let's scroll down once again. Okay, so as we saw over here, a free falling stone, a car moving on the road. How is this kinetic energy? Well, this is kinetic energy because let's say you one day decide to become naughty and you're like, I'm going to go and throw some stones down. For no reason at all, but you do so. So you are at the top of this building over here, and this is how much the height is. Say the height over here is 10 meters. Okay, let's take 10 meters. So the height over here is 10 meters. And you throw a object or a rock down, right? You throw a rock down. The mass of the rock, say it is say 1 kg. Okay? And this object, it goes so fast down that within a second of time frame, it just goes and hits the ground. Now, remember the factors that I just read. Mass of the object and the speed of the object. Now, are the puzzles coming along? Well, I think they are. Because the mass of the object was only 1 kg, but the distance was 10 meters. So, the object went within a 1 second of a time frame. So, the mass of the object is greater the mass of the object, more the kinetic energy definitely, because it will take more time, right? It's almost like more heavier. It will take more time to go down. And the speed of the object will be greater the speed of the object, more its kinetic energy again. So it's almost like the mass is directly proportional to if the object is more heavier. Greater the mass, more its kinetic energy. So mass is directly proportional to the kinetic energy, and so is speed. So now you understand. This is why a free falling stone or a car moving on the road, a ball rolling on the ground, and a bullet fired from a gun is an example of kinetic energy. Similarly, let's take one more, okay? Bullet fired from the gun. If the bullet is really very small and thin, okay, and the speed of the bullet that is being thrown is very fast. The bullet will hit a man. Okay, I'm not killing anyone. I'm sorry. I'm just saying this. So imagine the bullet is fired with a great distance. So it will hit the person in front more easier or more faster. And the person will more likely to get hurt, right? In this case. But if I would be very close and the bullet would be so very big, okay, very big and very large in size, and I would just throw it from my hand without a bullet, will that person get hurt? Definitely not. So over here you can see the speed. The speed is what matters, and the speed is what hits that person on any of his body part. So now let's read these factors again. Mass of the object, speed of the object. I think you all understood this now, right? If you have any doubts, please feel free to put it in the comment section. I'll be really very happy to solve your doubts. Okay, so the expression for kinetic energy is kinetic energy of the object of mass m moving with the velocity v is given that kinetic energy is half into mass into velocity squared. That's ke equals to half mv squared. So let's do some problems over here now. That's why I said you're going to have some maths, but this is fun maths. Okay, so calculate the kinetic energy of a bullet of mass 60 grams moving with a velocity of 100 meter per second. So here the mass of the bullet is 60 grams. So 60 grams will be changed to kgs. That will be 0.06 kgs. And remember the formula that we just read. Kinetic energy Ke equals to half mv squared. So what will be the expression? Let's take this, okay? So half into 0.06 into 100 squared, because it's velocity squared, right? Okay, so since it's a multiplication, let's do one thing. 0.06, right? And 100 has, if it's squared, how many zeros will it have? It'll have 4 zeros. So 1, 2. Let's take this over here. Therefore, it will be equal to half into 6. So 2 zeros are gone into 100. So half into 6 into 100. 2 ones are 2 50s are. What is 50 into 6? 0, 3. 300. Therefore, the answer is 300 joules. So the kinetic energy that is possessed by the bullet of mass 0.06 kgs and 100 meter per second is 300 joules. Thus the kinetic energy of the bullet is 300 joules. Very good. Let's go on to the next question. As always, I'll give you 2 questions for your homework, so remember to do it. An object of mass 25 kgs is moving with a velocity of 6 meter per second. What is the kinetic energy of the object? I think again very easy. 2 into 25 into 36. 6 into 6 is 36, right? Okay. So over here 2 ones are or let's say if it's 6 only. And or how do you want to do it? Okay, let's do this like this only. So 18 plus 18 is 36. So we'll do this. Now what is 25 into 18? Let's see. So 25 into 18 will be 0, 4, 16, 20, 5 equals to will be 200 plus 250, 0, 5, 4. Okay, so the answer is 450 joules. Let's see if you're right. And yes, we are. Okay. Now, as always, as I said, I'll give you 2 questions for homework. So note this question down. Example number 7 and example number 8. So this is example number 7. Try solving it without seeing the answer. Please. And this will be question number 8. Perfect. Now, let's go on to the second form of mechanical energy, which is potential energy. So the energy possessed by an object due to its position or configuration, shape or size is called potential energy. It is the work done in bringing the object to that state of or position. For example, water stored in a dam has potential energy. This potential energy is equal to the work done in storing the water at the height of the dam. Similarly, a spring compressed possesses potential energy that is equal to the work done in compressing the spring. Okay, so over here, potential energy means the energy that is possessed by an object due to its position or configuration, that is, shape or size of an object, is called potential energy. So if I take a rubber band, okay, and if I really pull it really very high, okay, and I pull it till here, and when I leave it, it goes back here. So this rubber band that you're pulling over here has potential energy because you're changing the shape or size of the object. And tell me, when you leave it, what will it have? I think the smart ones among you must have guessed it. Well, it will be kinetic energy. Just because and solely because when you leave this object over here to go here, right? It goes with kinetic energy. Why? Because over here the speed is mattering. As in, the speed matters, not mattering, I'm sorry, that's not a word. So the speed matters over here. If you stretch it, say, until here, so it will go more faster. So the speed over here matters. So when you're stretching it, it takes potential energy. But when you leave it, it takes kinetic energy. Let's see some examples. So there are two types of potential energy, that's elastic and gravitational. So elastic, I think, is very easy for all of you to understand. The energy possessed by an object when it is stressed or stretched, compressed, or even bent is called elastic potential energy. A stretched rubber sling of a catapult and a stretched bow possesses elastic potential energy. So again, as I took the bow and arrow example, I'll take it over here as well. So you have a bow, and this is your arrow. You stretch it really very far. So over here, it has the elastic potential energy. But when you leave it, it changes into kinetic energy. This is also how potential changes into kinetic energy, which I will tell you more about in the coming few minutes. So a stretched rubber sling of a catapult or a stretched bow possesses elastic potential energy. Hope you all understood this. Now let's move on to gravitational potential energy. So the energy possessed by an object due to its position above the ground is called the gravitational potential energy. A raised hammer has gravitational potential energy. It possesses this energy of its position at a height. So this is because whenever you are raising, this is your ground, okay, this is the ground, and you are raising a certain ball above the ground, it will be said to have gravitational potential energy. Why? Because gravity works like this. The ball is right here. You are going against the gravity by taking the ball above right here. So that is why it is said to have gravitational potential energy. And that is why a raised hammer also has it. So over here, you raise the hammer to go and hit the nail. Right? Again, you're going or acting opposite to the gravitational potential energy. And that is why this is said to have energy. To be specific, potential energy. Okay, very good. Now, let's talk about one more example. Similarly, water stored at a height in a dam and a stone on the high hill possesses gravitational potential energy, and when it is left, it possesses kinetic energy. So let's take a thinking question over here. Think. A boy drops a ball from the roof of his house. What kind of energy is possessed by the ball? Which force is acting on the ball? I'll give you 5 seconds to think. 5, 4, 3, 2, and 1. Time up. Now, let me tell you. Well, this definitely is gravitational potential energy. Just because if he's dropping the ball from the roof of his house. Oh, wait. I am extremely sorry. I didn't read the question saying that he's dropping the ball. So over here, these textbook people are trying to trick us while saying that, hey, it is above the ground, so it should be gravitational potential energy. But well, it really shouldn't. Why? Because if it's at a certain height, this over here will be the gravitational potential energy at this. But when you're dropping it down, the mass and the speed matters. And ting ting ting, this is related to the kinetic energy. Right? So it possesses the kinetic energy, and the force that is acting on the ball will definitely be the gravitational force, you can say, because you're going, the gravitational force, just because the gravitational force acts this words, and the ball, it's going down because of the gravitational force. It wouldn't go down if there wasn't any gravitational force, definitely. Now, let's talk about the expression for the gravitational potential energy. So, when an object is taken from the ground to a height, work is done on the object against the force. 1 minute. Yes. So, when an object is taken from the ground to a height, work is done on the object against the force of gravity. This work done is stored in the object in the form of gravitational potential energy. So the energy is stored, and now it is capable of doing work. So the ball over there is capable of doing work. So let's take this. Let's take an object of mass m be raised to a height h above the ground. So the minimum force required to lift the object is equal to the force of gravity on the object acting vertically downwards. When g is the force of gravity on an object of mass 1 kg, the force of gravity on the object of mass m will be F equals to m into g. F equals to mg, distance moved will be d equals to g. Work done will be W equals to F into d, and therefore work done will be m into g into h. And that's why we say V or W equals to mgh. That's mass, the gravity, and the height. Understood? Okay. Thus, we conclude that gravitational potential energy depends upon the following factors. So first, definitely the mass of the object, because the greater the mass of the object, the more will be the potential energy stored in it. Because definitely, if the mass is greater, the potential energy will also be stored in it more. For example, when we drop two objects of different masses from the same height of the nails, the object with greater mass will drive the nail deeper, right? And not the one which is lesser, because this is more. So the mass of this is more, and this will push the nail more, apart from this, which is still here. So if the nail was here originally in the object 1, it will probably go till here, and an object 2 will still stay here, because it depends on the mass, right? And then definitely the height of which the object is placed, this one is dependent on the gravitational potential energy, that the greater the height at which the object is placed, the more is the potential energy stored in it. I want all of you to mark this in your textbooks, or just note this down in your book or your notebook. Write it as notes and note this down, because this will really help you during your examinations. Okay, so let's do some questions. We have a total of, so as always, I'll give you 2 for homework, and then the rest we'll do. Example number 9. An object of mass 35 kgs is raised to a height of 15 meters. Calculate the potential energy by the object. Use gravity as 10 meter per second. So gravity will always stay constant. It's always 10 meter per second. Remember this. Okay, so over here again, potential energy is mgh. So PE will be equal to 35 into 15 into 10. So 35 into 10 will be 350, and 350 into 15. So let's see this. We'll do 35 into 15 itself. 5, 2, 15, 16, 17, 5, 3. So 1, 5. Okay, cool. So it will be 5250 joules. Am I right? Yes, I am. So this will be the answer. Hence, the potential energy stored in the object is 5250 joules, or 5250 joules. Now, second one. Potential energy of an object when drop from a height of 9 meters is 36,000 joules. What is the mass of the object? So over here, the potential energy is given as 3600 joules. That's 3600 equals to 9 meters into 10 into, let's say this is x. Okay, so we've got 3600 joules equals to 90 into x. So we'll move this over here and we'll do by 90. 0 cut. Let's say this ones are 40. And therefore, the mass of the object will be 40 kgs. And we are right. Like next to our as homework, so note this down. And also the next one down. This one. Okay, perfect. So now let's move on to the conversion of potential energy into kinetic energy. Right? As I said before, also potential and kinetic energy are extremely similar. They're almost like little buddies. So if energy and the work, they're two brothers. They also have two sons, named as kinetic and potential energy. So an energy has two sons, which is kinetic and potential energy. It's like they're brothers, and these both are also brothers. They always stay together, and yes. So the conversion of potential energy into kinetic energy will look something like this. Okay, so let's take an example right over here. A ball placed at a height possesses only potential energy. When it is released, it falls down and its height from the ground decreases. Therefore, its potential energy decreases. Therefore, as the ball falls, its potential energy changes into kinetic energy, due to which the velocity of the ball increases. So over here, what is happening is, this is your ground, and this is the distance. Okay, so this is the ground level. Okay, yes, so this is the ground level. So the ball is raised to a certain height, say, or this whole conversion is 10 meters. So it is raised up to 10 meters. Over here, it only and only has potential energy. That's gravitational potential energy. Because the velocity or the mass, none of it matters over here. When it's dropped down, the kinetic energy will be there. So when it's dropped down, the potential energy changes to kinetic energy slowly. And that is why they have both potential energy and kinetic energy. Why? Because the potential energy that was stored in the energy, the capacity of doing work over here matters, right? The potential energy which was stored over here is being thrown down to be converted into kinetic energy. That's why over here it has both potential energy and kinetic energy. But from here, if it goes down to the level C, it only and only has kinetic energy, because no shape and size is mattering over here. Definitely. Only the potential energy is also not mattering, because no shape or size, as I said, is not mattering over here. Not mattering, I'm sorry. It doesn't matter over here. I keep saying mattering. I'm extremely sorry. It's not a word. Okay, so it does not matter over here, and that is why. And actually, why doesn't it matter over here? Does anyone know? If you do, please write it in the comment sections. For now, I'll tell it. Okay, so it doesn't matter because the shape or size isn't being changed. It isn't being lifted to a certain height. That is why only the kinetic energy matters at the level C. So A is potential energy, B is kinetic energy and potential energy, and C is only kinetic energy. Let's go to the next sum. This one is our hot favorite, right? The bow and arrow, which I've said a lot of times. Let's take it once more. So the bow is over here, and this is your arrow. So when you're stretching it, the elastic potential energy is being used. When you throw it, the velocity by which it is going, the kinetic energy matters. So the potential energy, once again, is changing into kinetic energy. Okay, let's take the next sum. So a ball placed on a compressed spring flies away when the spring is released. So over here, again, elastic potential energy, because you're putting the ball down right here. So the energy, it is stored in the spring as potential energy. And when you leave the spring, the velocity and the mass matters over here. So the potential energy changes into kinetic energy. Okay, now we have the wound up spring of a watch has potential energy. It's almost similar like the one we saw before, that the spring of the watch that we have, it has potential energy, and that is solely because the work done in the wounding the spring gets stored as potential energy, and when the spring unwinds itself, the potential energy changes into kinetic energy. Again, very very similar to the one we did earlier. Then the water stored in the reservoir of a dam has potential energy because first it's at a height, definitely, so it possesses kinetic energy. But then the water, the velocity it goes through over here, the potential energy once again changes into kinetic energy. As a result, the turbine rotates and the electricity is produced from the generator right here. Okay, now let's take this one, the pendulum. So consider a pendulum bob of mass m suspended by a string from a rigid support S. Now let the bob oscillate between three positions A, B and C. Both A and C are called extreme positions and B is called mean positions of the bob. So over here what is happening, the potential energy over here, the height is this much. So the potential energy over here is max. When it's left over here, the potential energy is 0, but the kinetic energy over here is max. But once again, if it goes over here, the potential energy will be max and the kinetic energy will be 0. Let's understand this a little more better. Okay, so when the bob is moved from a position B to the position C, it is raised to a height h, definitely. So the height is h over here. So let's take the height h, and gains potential energy equal to mgh. At position C, it only has kinetic energy and no so it only has potential energy and no kinetic energy. Why? Again, because it is raised to a height h. When the bob comes back to position B, its potential energy decreases to 0 and kinetic energy becomes maximum. And hence at position B it only has kinetic energy and it has no potential energy. So at the two extreme sides, that will, you can say that's A and C, the kinetic energy is maximum, but at B only the kinetic energy is maximum. I'm sorry, I'll reframe that. A and C, the potential energy is maximum, and B, the kinetic energy is maximum. I know potential kinetic a little confusing, but trust me, it won't be. Just solve more sums, understand if you want, rewatch this video and you'll get there, trust me. Okay, so now let's look at the differences between the potential and the kinetic energy. So kinetic energy is the energy possessed by an object due to its motion, and the potential energy, it is the energy possessed by an object due to its position or configuration, that is shape or size. It is the kinetic energy is equal to the work done on the object in moving the object initially from rest, and it is equal to the work done in bringing the object to that state or position in which it is initially at rest. And kinetic energy will be, it can change to any form of energy at all, and potential energy, it can only and only change into kinetic energy. Well, with that, we come to an end of energy. Hope you all understood this video and really just again understood about energy, what kinetic energy is, what mechanical energy is, and of course what potential energy is. If you have any doubts, feel free to put it in the comment section. Like and subscribe, and I'll see you all next time. Bye.